So if I'm tracking things correctly based on our conclusions from chapter 1, if I react this piece of magnesium metal with this solution of hydrochloric acid, both of which are made up of atoms, magnesium metal is made up of magnesium atoms, and the hydrochloric acid solution is made up of hydrogen and chlorine atoms, that the number of magnesium atoms will be the same before and after, the number of hydrogen atoms will be the same before and after, and the number of chlorine atoms will be the same before and after. Let's just take a quick look at this piece of magnesium. So there's the magnesium metal, and of course here's the hydrochloric acid. It's actually diluted in water. So theoretically what we're saying is that the number of atoms before the reaction will equal the number of atoms after the reaction. And that may mean, hopefully that means, that we can actually go one step further and not just say that the number of atoms before is equal to the number of atoms after, but can we say something about the arrangement of the atoms before and after? And so that's the goal or quest for this lab. Can we actually say something about the fate of the magnesium atom and the fate of every hydrogen and chlorine atom? So let's dig into a couple ideas first before we get into the lab. So the reactants in this experiment, of course we know what they are. We're the ones causing the reaction. So the reactants are magnesium metal, which is made up of magnesium atoms, and hydrochloric acid, which is made up of hydrochloric acid molecules. Some possible ideas of products. Let's just hypothesize on possible ideas of products and how these, and the products will tell us how these atoms change, at least insofar as their arrangement. So one possible thing that could be produced is some sort of, super compound, super chemical called, MgHCl. So maybe this Mg just bonds with, this Mg atom bonds with hydrochloric acid molecules and forms this MgHCl, super molecule. Maybe the magnesium bonds with hydrogen and frees up the chlorine. So I have some molecule, magnesium hydride or something like that, just making up names, and chlorine gas. And I know, so I'm just telling you right now, that when chlorine is by itself, it always has, there's always two chlorines sort of paired together. You'll never see a chlorine atom kind of by itself. A third possibility is maybe the magnesium just causes the hydrochloric acid molecule to separate. And just like chlorine, hydrogen gas is always found in a diatomic state. That means there's always two paired together. You'll never see a hydrogen atom by itself. It's always H2. So these are just three possibilities of what could be produced if I react magnesium and hydrochloric acid. Now I'm sure there's other possibilities. You can mix and match and do whatever you want. But we'll do the experiment and see if we can make a deduction. And ultimately we want to build out the chemical equation. And so a chemical equation will look like this. Mg plus HCl goes to or equals, and so on the right side of this equation, it could be this, it could be this, it could be this, or it could be something else. And so this is our goal, is to simply react magnesium and hydrochloric acid and see what comes out on the other end. And there'll be a nice little test we can do which will help us, and I'll get to that in the lab video.